Okay, today we're going to talk about how we can get our shaders to communicate with our code, and we're also going to make a simple checkpoint system because we can. Let's do it. So we're going to start by creating a new folder for our checkpoints. I'm going to create a folder. It's going to be called checkpoints. In here, we're going to create a C# script, and it's going to be called checkpoint handler, or whatever you want to call it, doesn't really matter. I already have one called checkpoint as well. Then we're going to create a shader graph, URP lit shader graph. Hopefully you are in URP at this point. If you're not and that's not showing up, download URP because you can't do anything without it, and you really should be in URP. Or HDRP will work as well. Anyways, with our shader graph, let's call it shader underscore checkpoint. And for me, it's going to be checkpoint 2 because I already have one. And then we're going to create another one. It's going to right click on shader graph, create material, just like this. And we're going to call it m underscore material underscore current checkpoint. Okay, and then apply it to both of the things. Why is it pink? Why is this empty? Weird. Okay, so my graph was not set up correctly, but now it is. Odd. All right, anyways, in our graph is going to be really straightforward. We're going to create two variables here, a float called percent, which is the percent of change, and we're going to create a gradient that's going to be called color gradient. That's it. On the percent, and this is optional, change the mode to slider. That'll make it easier to test. On the gradient, press on the color and let's make a gradient. At the bottom are our color keys. So what we want to do is we want to add a key somewhere like here, move this key over a little bit, whoops, and then just like this. And then what we can do is we can set this one to be red, and then this one to be green, and then this one to glow. So like set it to D2. And let's turn from blending classic to fixed. And we get like this. Okay. And again, we've got a bit of intensity. Great. Now we're going to do the shader quickly. It's actually almost done. Drag and drop them both into here. We're going to say from color gradient, we're going to sample gradient. It's the only thing it can do. And then as our time is percent. And then the output is going to be both the color and emission, which is very lazy, but that's okay. That's all we're doing. You can obviously do more with this. Anything that we have done, you can do with this as well. Great, and there it is. So now on our material, we have the ability to change the percent. And you see that it blinks white. Now, if yours is not flashing, there's one of two things. For me, it's my intensity is not high enough. If you go to your global volume, and if you don't have one, then you need to make one. It's just a component that's called volume, but you need URP for it. And make sure you have bloom enabled. My bloom threshold is too high, so when it glows, it's not going to be visible. And my intensity was too low, or too. Actually, my intensity was fine. But here we go. Now, there you go. It'll glow. So we'll play it, and this is what you'll see it looks like. Little blink. And you can mess with these a bit, and that's how you can kind of get your desired effect. Blink. Cool. Now it's time for the script. So open the checkpoint script. And the first thing that we're going to do is we're just going to set up the CPU to our shader. And then at that point, you're technically done. But I recommend that you stay if you want to learn some good C++, C#, C# things. So we're going to say serialized field, private, float, range, or percent. And this is going to be a temporary variable. So let's also add range here and say it's between 0 and 1. It's going to be our temporary percent slider. Then we're going to create another variable so we can access our shader properties. We're going to say private static read-only int, and it's going to be called percent ID. And we're going to set it equal to shader dot read value or property shader dot property to ID. There you go, just like that. Now we said static because we only need to create this once, and read only because we can create it as soon as the game starts, which is really nice when it's compiled actually. And then shader.property to ID, meaning we are computing our property ID. So in here we have our percent, and what we can do is we can say, whoops, our percent as our reference, and this is the value we want. So make sure when you click on your variable, it's this reference here. If you wanted to do your gradients, it would be that, but I'm going to copy my reference and I'm going to paste it in here, and that should work. And if you don't do exactly that, it's just not going to work. Then we're going to create another variable. It's going to be a private and then material, so we can actually change our shader, and it's going to be called myMet for my material. And then in start, we're going to say my material is equal to get component type of material, or get component type of mesh renderer, because our mesh renderer stores our material. There it is. And then finally, in update, we're going to say my material dot and then set float %id %. And just like that, our logic is now done, and we've hooked up our code. So now when I press play, I can individually change them. Oh, and I forgot to apply the scripts. So on each of your objects, you're going to have to make two and drag them into your scene. And I'm just going to remove their old components, because I have those. Put the components in both of them. And then if you want to continue, make sure that both of their colliders are box colliders. So I have my checkpoint handler, which is the new script. And now, there you go. And if I only have one selected, then only one does it. And if I have the other one, and there you go. Great. So now let's move on to actually making this a system on its own. So in checkpoint handler, we're going to say private, not private. We're going to create sort of a singleton. There can only be one checkpoint that the player is bound to, right? So we're going to say public static, because there's only one checkpoint handler, and it's going to be called the current checkpoints. We're going to say get private set, so that way nobody is able to change us, but people are able to get us. Now, if you want it to be really safe, then you could also do something like this. You could say public static vector3 get checkpoint position. And then you would say return current checkpoint transform position. And what this would do is it would prevent anyone from being able to like break a checkpoint in any way. It would mean that the only thing the player has access to is this, the position that they're supposed to teleport back to. In our case, we're going to be a little lazy and we're just going to do this. But yeah, something to be aware of. We no longer need the update function, so let's delete it. And instead, we're going to make three new functions. We're going to make onTriggerEnter. We're going to make a custom one, a private void reset color. And we're going to make another one, a private timer enumerator, and then it's going to be called set color. Okay. So from here, we're going to start in onTriggerEnter. We're going to say if there is a current checkpoint. So if there is a current checkpoint, so we're going to say current checkpoint is not null, then we're going to say reset color. But before we do that, we need to make sure that we are not that checkpoint. So we're going to say if current checkpoint is this, then return. So if we are the checkpoint, if we are the current checkpoints, then return stop code. Okay, and then reset the color, that's pretty obvious. And then after this, okay, we need to set our color. So we're going to say that current checkpoint is equal to us, and then we're going to start our coroutine. So we're going to start a timer for the set color function, and that's now done. Now in the reset color function, what we're going to do is we're going to say my material set float %id to 0, and that's literally it. There's actually a problem over here. I'm sorry. It's not just reset color, because if we did that, we're going to reset our color. So we need to reset current checkpoint color. So we're resetting the color of the current checkpoints. And then all we're doing is we're setting the float of that to 0. That's it. Okay, and then in set color over here, we're going to say float current time equals 0. So starting at 0, while the current time is less than duration, which doesn't exist yet. We're going to say current time plus equals the time between frames, so time delta time. And then we're going to say my material dot set floats percent ID. And it's going to be the current time divided by the end time, which is just like how you would get your mark in school. If you got an 8 out of 10 on a test, you got an 80%. It's the exact same logic we're doing here. And then we're going to say yield return null. Wait until next frame. Wait until next frame. And then that's literally it. Actually, there's one thing that I missed. Sorry. In reset color, let's add stop all coroutines. And what that's going to do is it's going to make sure that if you have like a bunch of checkpoints in a similar area, it's going to prevent them from accidentally overlapping and running multiple times. And then finally, we need to add the duration variable. So let's go back to the top and change percent that we're not using anymore to duration. And then remove the range here. And that's it. So now if I go into my game, and let's change their defaults to both be 0. Oh, I have made an oopsie. If their duration is 0, then their timer's not going to run at all, right? So change their duration to 0.2. Or some other number. 0.2 is just a suggestion. And there you go. So now you can only step on one at a time, and the other one will turn off when the other one turns on. And now here's what's really, really cool about this. If you go to any other script, because we have this as a static property that we can access, we can go to player, for example, and when our player is moving, we can do this. We can say if, and then the checkpoint handler is the name of the script, dot current checkpoint. And then if we have a checkpoint, then what we should do is let's print the checkpoint. So checkpoint handler dot current checkpoint, and then let's get its name. And then you can just see this is working, but you can do whatever you want with this. So you can have it teleport the player, you can have it spawn an enemy, you can do whatever you want. And the concept hopefully is applicable to other things you're doing in your games. There you go. This says check A, and this says check B. And this says check A, and that's it. And if I wanted to, I could have like a kill box if my player exceeds a certain Y, and then I can teleport back to it. Let's add that quickly just to show you that this is actually working. An update, if the transform position dot Y is smaller than 10, smaller than -10, then transform dot position equals current checkpoint, or checkpoint handler dot current checkpoint dot position dot transform position, and then plus vector 3 up multiplied, or just plus vector 3 up, that's good. Just because it's a little bit in the ground for me. You don't have to do the vector 3 up. And I hit the checkpoint and I fall off. And I hit this checkpoint and I fall off. And that's it. Easy peasy.